Okay, we're only doing numbers 1 through 4, the ready right now, so let's take a look at Pythagorean, see if you remember how to do this. You might remember from middle school, the Pythagorean theorem was taught to us as a squared plus b squared equals c squared, but in Math 2, we like to refer to it as leg squared plus leg squared equals hypotenuse squared, so that you're using the actual names for each leg. We know what the hypotenuse is, the longest side, and A and B make us feel like we need to use those variables every time, but sometimes we use other variables and it can confuse kids. So it doesn't matter, but basically the theorem states the sum of the squares of the two legs is equal to the hypotenuse squared. So let's write it that way. Okay, here we go. Number 1, I'm being given two legs and I'm asked to find the missing hypotenuse. How do I find it's a missing hypotenuse? Because the right angle is here and the hypotenuse is always the longest side across from the right angle. So I say leg squared plus leg squared is equal to the hypotenuse squared. And it doesn't matter which length is which leg first or second. It doesn't matter. I can use the 5 and the 12 or the 12 and the 5. 5 squared is 25. 12 times 12 is 144. So we add that together and get 169. Grab your calculator or your phone calculator right now and do 169. Take the square root of both sides. And we get the hypotenuse is equal to an exact 13. If we don't tell you feet, inches, centimeters, if we don't tell you units, you are going to just write U for units. Okay, so our missing side, our hypotenuse, the square root of 169 is just 13. That one came out to a whole number. Let's check out the next one. All right, on this one, we got the hypotenuse as square root of 10. Okay, let's go see what we can do with that. So I'm going to go leg squared plus leg squared equals hypotenuse squared. And this time I'm given a leg, but there's an unknown right here. I'm going to call that x. And then the hypotenuse is the root 10 squared. But the square root of anything squared, those just cancel each other out. Oops. So 3 squared is 9. But square root of 10 squared is just 10. It's like the squared erases the square root. We've seen that happen on completing the square problems before. Now I'm left with x squared, our unknown missing leg, equal to 1. So I square root both sides, and I get that x equals 1. And I'm not given any units here or anything, so I just say 1 unit. Okay. Pause the video, try the next one, number 3 on your own. Okay, let's see how you did. So this time our unknown is also a leg, and we're given the longest side of 4. 1 times 1 is just 1. 4 times 4 is 16. When we subtract 1, we get that x squared is equal to 15. So we're like, uh-oh, well, that's kind of weird because when I take the square root of 15, that doesn't work out to a whole number. And so the answer is sometimes we just leave our answer in radical form, but also you can give this answer as a decimal form by just taking the square root of 15. And we get 3.87. Root 15 is our exact answer of the length of the side, and approximately 3.87 is the approximate answer of the missing side. So I wasn't given any other units, so I just say units. So exact answer, root 15, approximate answer, 3.87. We rounded, so we used the approximation symbol, and we say U for units, or just write the word units. And then for the exact answer, we use an equal sign because it's exact. All right, pause the video, try number 4, see how you do. Okay, this time I was given a hypotenuse and I'm missing a leg. So we go leg squared plus leg squared equals hypotenuse squared. And we have a root 27 right here. We have an unknown x, and the hypotenuse is 6. So 27 squared, root 27 squared, that is just 27. Yay! And 6 squared is 36. So what is 16 minus 7? Is just 9. Square root of both sides, x equals 3. Square root of 9 is just 3. So x equals 3 units. It's a nice equal sign, not an approximate, because it is a whole number, and we didn't have to do any rounding. Okay, so here were our 4 answers. Make sure you've highlighted them so they stand out. Okay, all done. How are you feeling on Pythagorean?